Hello everyone, so today I'm going to walk you through some of the basics on how to use the chain rule when taking the derivative. I hope some of you are already familiar with some of the basic rules of differentiation. Let's say, for example, the product rule. If you have two functions that are being multiplied, then you take the derivative of the first one times the second one plus the first one times the derivative of the second one. So I hope you're familiar with that. Also with some of the basic rules like the power rule when you're taking the derivative of an x raised to something or a variable raised to a number. Well, what we would do here is bring the number down, bring the exponent down, then the variable there, and subtract 1 from the power, right? I hope you're familiar with these rules, maybe also the exponential rule, right? So taking the derivative of something like this will be having the same thing, right, times the natural logarithm of the base, and that will be it. So we're going to use some of these rules throughout the video, but just to have them there, Okay, so let's say we have something a bit more complicated than these previous ones. Let's say something like this. 5x squared plus 6 raised to the second. Now, how would we take the derivative of that? What we need to do then is, well, let's just try and figure out a way of simplifying this and check if there is a pattern that we can find in something like that. Now, let's try and split this into two things, right? Into two multiplied expressions, so that we can use this rule right here, the product rule, right? Okay, I have my first function right here. I have my second function right here. So what we're going to do is we're going to take the derivative of this, right? With the product rule. So the derivative of that is going to be the first one. This first one right here, the derivative of that is going to be 10x. This goes down, and 2 minus 1 is 1, so that goes there. And the 6 is a constant, so that just disappears. Then times the second function, 5x squared plus 6, plus the first function, 5x squared plus 6, times the derivative of the second. So 10x. Okay, maybe we can simplify this a bit further to see if there is something that we can spot. Well, right out of the bat, we see this has a 10x and this has a 5x squared plus 6, right? That's our first term right there. The second term has also a 10x and a 5x squared plus 6. So what we can do is we can join them together by adding them. 2 times 10x times the 5x squared plus 6, right? Because there's two of them, right? This first term plus the second term. Right? We just join them together. Now, here's the interesting part. You can see here, we can just rearrange this a little bit more. Put the 2 here. 5x squared plus 6 times 10x. Here's the interesting part. Let's compare this to what we started with, right? Let's compare this. So d 5x squared plus 6 squared dx. Now, what can we spot from here? Well, we see there's a 2 right here and an exponent of 1 in this case. And that the inside here remain the same. So let's see, maybe if I replace that inside with a u, I'm going to be able to see that something interesting happened here. Because what we have there started out as a 5x squared plus 6 raised to the second. Well, that's now that we say, okay, that u is going to be whatever is inside those parentheses. So let's just rewrite it in terms of u. So we had u squared at the beginning, right? dx, let's say, and u is going to be that inside, right? U is going to be that 5x squared plus 6. And when we took the derivative, we ended up with 2 times the u raised to the first power times this thing, right? But let's focus on this part first. Like, let's just leave that 10x aside. And let's focus on this part first. This is very, very similar to what we had here, to a power rule. Because the power came down, and then we subtracted 1 from the power, right? Hey, this is very familiar. Now, we started with something like a very big expression raised to a power, and we ended up using something really similar to the power rule. But what is this 10x? What does that 10x mean? Well, the 10x, how did we get that 10x in the first place? We took the derivative of what was inside, right? We took the derivative of this. The derivative of 5x squared is 10x. So this right here is a derivative of that inside. So that's how the chain rule works. Essentially, you start up with a big expression that falls into one of these categories, into one of the rules that you see, but instead of an x right there, it's going to have a function. It's going to have a bunch of expressions, a big expression inside some other function, right? So we can generalize this by saying, okay, something, the derivative of that thing that is raised to a power is going to be, we use the power rule, right? Bring the exponent down and then subtract 1 here, times the derivative of what was inside that power rule. So let's see this in a practical setting, right? This is like the generalization of the power rule with a chain rule involved. Now let's see some examples of that. Okay, so let's say we had some expression like this one. F of x equals 6x squared plus 7x, all of that raised to the 4th. So the first thing to solve that using the chain rule is we need to identify what the inner function is. What do I mean by that? Well, what is being affected by an operator? What is the outermost operator that is affecting the most things? In this case, we can see that this right here, this operation of raising to the 4th, is affecting all of this inside. Which means that this inside right here is sort of like the inner function. Like this looks like something raised to the 4th, right? If I were to replace all of that thing inside with a u, then it will be u to the 4th. So we just found the inner function. What do we do now? Okay, what we're going to do is then we're going to take the derivative. And how do we take the derivative of this? Essentially, for taking the derivative here, we use the power rule, right? Because this right here is just a power expression with an inner function right there. So let's just treat this as a normal power rule, and let's bring the power down, right? 4 down, times the inside stays the same, right? And then we subtract 1 from the power here, Right, so that's our general power rule. But the thing is, we haven't dealt with the inside yet. So what we need to do now is, after that, is take the derivative of the inside. Right. So let's simplify now what we have. So we have 4 times 6x squared plus 7x. All of that raised to the 4 minus 1 is 3. Times, what is the derivative of 6x squared? That's 12x. Plus the derivative of 7x is 7. And this is the derivative of our first expression. Right, let's do some other examples. So let's say we had this expression. G of t is 4t squared minus 3t plus 2, all of that raised to negative t. Let's identify the inner function first. You can see what is affecting the most things is that negative 2 raised to negative 2, and what is inside the parentheses is all of that. So that's our inner function right there. I'm going to highlight it, and you can see better now that all of that is inside the parentheses is our inner function. Right, so once we have identified our inner function, what we're going to do is we're going to check, oh, well, this seems like a power rule. So we are going to apply the power rule in this case. The derivative of g of t with respect to t is, we're going to bring that down, negative 2. And then we have the inside, we don't touch it yet. We're doing the derivative of the outer function, the derivative of that power rule right here. Now we had negative 2, so we have negative 2 here, and then we subtract 1, right, because of the power rule. So that's the derivative of the outer function. Now we need to deal with the inside and do the derivative of the inner function, the derivative of all of that. T squared minus 3t plus 2, the derivative of that. Okay, so let's simplify what we've got. 4t squared minus 3t plus 2 minus 3 there, times the derivative of our inside, which is 4 times 2 is 8. Oops. 8t, 2 minus 1 is just 1, minus 3. Right, this is a 1 that goes down, 1 minus 1 is 0, so this goes away, and this goes away as well because it's a constant. Here we got it. This is how you deal with functions that are big and that are under a big operation, right? So in this case, we can clearly see the pattern of, okay, that was the inner function. We brought the power down, and then we subtracted 1 from the power. After that, we multiplied by the derivative of the inside. So I hope that gives a general understanding of how to use the chain rule with the power rule. And I will see you in the next time.